The bruise threshold for a fruit is the highest height it can be dropped from rest without bruising. The bruise threshold of a 0.2 kilogram apple on steel is 10 centimeters. Suppose that it always takes 0.1 seconds after impact for the apple to fully stop, and that 4 square centimeters of the apple comes into contact with the surface during the impact. What minimum average pressure is required to cause the apple to bruise? So, I'm going to start by writing out some of the equations that we will probably use. So, the pressure is given as the force divided by area. It's just the force per unit area. It has units of pascals. And the other one we'll use is the impulse momentum theorem. And this says that the force times the time interval of the force is equal to the change in momentum, which we can write as the mass times the velocity, or simply the mass times the change in velocity if the mass is constant. So that's the impulse momentum theorem. And also, I'm going to quickly do some conversions here. So 10 centimeters is equal to, that's equal to 0.1 meters. We need to make sure to convert everything to meters or square meters to get this to work. And 4 square centimeters is equal to 4 times 10 to the negative 4 square meters. All right. So we need to find the pressure that causes it to bruise. So we know the area, but we don't know the force. So we need to solve for the force using this equation. But let's clarify some things in the equation first, since there are some unknowns. So the change in time, or the time interval, is equal to 0.1 seconds. That's what it says right here. And we need to calculate the change in velocity. So to do this, we can use energy conservation. So the initial potential energy of the apple must equal the final kinetic energy right before impact. So the initial potential energy is given by mgh, the mass times the gravitational acceleration times the height at which it was dropped. And that's going to be equal to the final kinetic energy it has, which is 1/2 times the mass times the velocity squared. So the masses cancel, and we can solve for v. So v squared is equal to 2gh. So v is the square root of 2gh. So that's our velocity. And the change in velocity is simply going to be what we just got. So the change in velocity is going to be the square root of 2gh. And this is because it's going to be coming to rest. So once it impacts and stops, the apple will fully stop. And so its final velocity is 0. So the change in velocity is simply the initial velocity that it had, which is the square root of 2 times the gravitational acceleration times the height. Okay, and now we have found everything that we need. So we can rearrange this. So this becomes the force is equal to the mass times the change in velocity, which is the square root of 2gh. And we're going to divide it by the time interval of 0.1 seconds. And we're also going to multiply by the area, since we're going to find the pressure. But right now, this is the expression for force. So pressure is just force divided by area. So it's this quantity divided by 0.1 times the area. Since we just need to divide the force by the area for the pressure. So now we can just substitute everything in. The mass is 0.2 kilograms times the square root of 2 times the gravitational acceleration is 9.8 meters per second squared. And the height was 10 centimeters or 0.1 meters. And we're going to divide it by 0.1 times the area, which we found to be, which is 4 square centimeters, or 4 times 10 to the negative 4 square meters. And now if we just plug this into a calculator, we get that the pressure, the minimum average pressure to cause a bruise, is equal to 7,000, it's not very good, 7,000 pascals, or newtons per square meter. So that is the pressure required for the apple to bruise. And that is how you would solve this problem here.